Now, what kind of a problem might you have to solve on your way to the moon?
The most basic problem is determine the position at any point in time, and that can be illustrated in these charts. The sextant shown here represents the spacecraft. And to determine the position, an angle must be measured between a point on the Earth and a star. And you can see that as you move away from the Earth, this angle would narrow down, thus giving the distance between the Earth and the spacecraft. The astronaut first positions the spacecraft so that a point on the Earth, a landmark, is visible through the sextant. Then he positions the sextant angle so that the star is superimposed upon this landmark.
Now, what kind of a landmark might he see?
This one is San Francisco Bay, as you can see here. However, the Great Lakes or Cuba or Cape Cod or the tip of Florida, any of these points make suitable landmarks.
And then through some system of mirrors, you actually superimpose the star on that.
That's
feature.
right. The mirrors inside the sextant will bring the star within the field of view so that he can superimpose it on the landmark.
Now, how is this angle actually measured?
It's done automatically via the computer. The astronaut must first identify to the computer the star and the landmark that he's planning to use. Then, as he's positioning the spacecraft and the sextant, the computer is measuring the angles between the two. When the astronaut is satisfied that the star is superimposed upon the landmark, he pushes the mark button, telling the computer to record these angles and the time of the measurement. From that information, the computer can compute the position of the spacecraft in space.
Well, now that you know the position, what can you do about it if it isn't right?
The computer can position the spacecraft, turn on the motors, and steer it, then shut the motors off.
So you'll be coasting on a new and corrected path.
That's right.